Okay, this weekend's project is going to be to improve my compressed air solution. Currently, I've been just running a hose right off an old compressor. This is a 22-gallon Campbell Hausfeld compressor. While this compressor is probably not my long-term solution, I'll be getting something bigger, but for right now, I'm going to stick with it. But I want to improve the quality of the air that it's putting out, and I'm going to do that in a couple ways. First of all, I'm going to use this MaxLine distribution system to be able to pipe compressed air throughout my shop. That's going to be one big improvement. But before it gets distributed, I want to clean the air. I want to clean it and I want to dry it. And I'm going to do that. I'm going to build a compressed air cooling radiator. This will help cool the air down. It'll help remove moisture and a little bit of debris. And what's going to be unique about the piece that I'm going to build, I've done a lot of research on the internet as well as a lot of great people sharing their solutions on YouTube. I'm going to add a little bit to that. Mine's going to be semi-auto draining. And so I'm going to put an auto drain piece on there, and I'm going to share with you exactly how that piece works. So that'll be kind of neat. I'm also going to share with you diagrams. Everything I've done here I've drawn up, and so there's some diagrams you can download and see if that may help you get started with your process. Some of the diagrams that I'm going to show while making this are incorrect. They actually, as I built it, I saw some errors and made some modifications, and so I've made those modifications to the drawings. The drawings that you can download are the final product, but you'll see where I make some assumptions and then finally make some corrections and make the system better. You know, it's a custom solution. It's on a wall. It's only 20 inches wide. It's a concrete wall, so I have to be real cognizant of a narrow space. But let me walk you through. This is what it looks like. It's air is going to enter in from the lower right hand side. It's going to travel up and down and then back up and down again and then exit out through a filter which will filter the air for moisture as well as for oil contaminants, and then it'll be distributed out the MaxLine distribution system. So with all that put together, I am going to now kind of walk you through step by step how I actually physically put this radiator together. And so I hope you enjoy following along. Okay, plan. Did I mention plan? Oh, I don't do much without a plan. Interestingly, you got to really consider all the different components you're hooking together. That dictates a lot of how you outline things. For instance, the air filter that's here, this actually, the flow of it, the air's got to flow through it this direction. So what I wanted to do, but I want to set this on top of this right in this area, and by doing that, I want my air to flow through my radiator from right to left. So it'll actually, air will come in through this T, run through this cooler this direction, come out of here, and then this is actually going to sit on top of here. It'll flow through the actual air filters and then connect to the MaxLine distribution system. So, one of the key things you got to consider all what you're connecting and how you're going to adapt to that. Once you get to copper, copper to copper is pretty easy, but when you're adapting from copper to, say, this filter, there's a lot of considerations there. But by sketching this out and I had 5 or 6 different ways I was going to do this. I finally settled on this. I was actually able to then come up with the number of different fittings that I needed. And then that kind of led myself to going out to my parents' house where I knew my dad had a bunch of this stuff. I found a box of fittings, and those things are about $3 a piece or so. So I was digging through there and I found exactly the pieces I need. I need 6 of these T's and I need 7 of these elbows. And so this part of the project's free. Between that, and then I also went to Home Depot and I picked up some long lengths of, these are 12-foot lengths or 10-foot lengths of 3/4 inch copper pipe. So I'll go there. Now one of the next things I want to do is just to kind of help improve my drawing is really figure out, I want this thing to look nice. I'm just kind of the way I am, is that these two are actually a little bit different. If this is the riser on that drawing, you notice that these end at a different place. So I've got to figure out what the difference is there so I can make sure that when I'm cutting these little cross members, this cross member goes between a T and an elbow. Up here at the top of the drawing, it goes between elbow and elbow. I want all this to kind of look the same. So where I originally drew these were those This little connector pipe there was going to be a 3-inch pipe. I'm going to have to make a little bit of adjustment to, I think these are going to have to be a little bit longer. And same thing with this will have to be a little bit longer, and I'll have to determine what that length's going to be. But I'll get all that proved up, and then ultimately we'll have that documented down here in this piece. And then this drawing, I'll go ahead and I'll attach this to my Google Drive and allow you to download this as maybe just a starting point for your project. But let's get some of those measurements worked out. Alright, let's take a look at our two different scenarios for connecting these two pipes. First of all, I did determine based on the wall that I'm going to put this on that I want these risers to be on 4-inch centers. So I just went ahead and sketched 2 lines that are 4 inches apart. I placed the two different scenarios of these fittings on here. If I got an elbow to elbow, which will be at the top in the center, if I center this fitting, I can measure that the distance between here is 3/4 inches. And I know on a 3/4 inch pipe, this cup is 3/4 inch deep. So I have to add a 3/4 inch here and 3/4 inch here. So the pipe that connects these two in this scenario needs to be 2 1/4 inches long. In this scenario, this piece is a little bit shorter, so I've got the same scenario on this side as I do down here, but after putting this in and measuring the distance, I got a 1 1/4 inch gap between the fittings here. When I add the 3/4 inch inset into the cup and the 3/4 inch insert into the cup here, I get a total of 2 3/4 inch piece of connecting pipe there. So I'm going to mark my drawing so I know how many of these to cut. I'll go ahead and cut. I'll cut a few of these, make sure that that looks right, but it should be right, and we'll be able to mass produce. I know exactly how many of these I'll need and how many of these I'll need based on my drawing, and we can get those cut out and cleaned up real quick. Okay, so cutting copper pipe's not that difficult. I went ahead and marked off my 2 1/4 inches. Got a rigid cutter here. Just going to open this up. It's big enough. And place that cutting head. Here's the cutter head here. We're going to put that on that mark. Tighten it up. Rotate this to a score. Scored it. Do a little tighten. Pops right off. Now the key to this is we're going to need to deburr this inside edge. We want that to be smooth. The outside edge is roughly smooth, but there's our 2 1/4 inch piece. I'm going to cut a couple of these and also cut a couple of the 2 3/4 inch pieces just so we can mock them up, make sure it looks like what we want. I'll be right back. Okay, so I got the two different sizes cut. I got them pushed in all the way, and sure enough, I still end up on my 4-inch center marks on both these items, so that's going to work out perfect. I went ahead and cut the rest of the long ones that I need for the rest of the drawing, and also that one extra shorter one I needed for the top. And then just what I now know, since I know now that these risers are on 4-inch centers, I know that these two risers outside to outside, that's 8 inches. That determines now where these T's go. I can now calculate what the length of this is, and what I intend to do next is I want to build. These valves are in the mail. They're coming tomorrow, but I know I can build this section down here. I can go ahead and prefab all that, get it put together, and then I'll go ahead and solder at least this bottom section together. I'll wait till the valves come, because I'm going to need some of that information to actually then determine some of the overall lengths of these other pipes. So let's work on that. Okay, since it's so quick to do these mock-ups, I went ahead and mocked up my 8-inch center on those two other pipes, and these elbows or these T's in this configuration, and the distance between them is 5 3/4. We got to sink in a 3/4 and 3/4. So this pipe's going to have to be, and this is pipe B on my current diagram, 7 1/4 inches. So I'll go ahead and cut that, and we'll start mocking this stuff up. Okay, so in preparation of putting all these together, we got to do a couple of things. On all the pipe fittings that we cut, we got to deburr this inside. If you get the larger pipe cutters, they typically have a big triangle metal piece. It's a reamer. You stick that in there and you can do that. This one doesn't come with that, with the smaller size. So I'm just going to take a pair of old lawn clippers and just basically go in here. You can see it cutting away that pinched area. Okay, that's smooth. I'll do that to both sides of all these pipes. That'll be the first thing I do, and I'm just going to, I'll do all those for all the pipes now, but then as I'm ready to use these, I won't do them until I'm ready to use them. But you also have, you need to clean up. This needs to be very, very clean and free of dirt and debris for a good, good solid solder joint so you don't have air leaks. So this little tool here, basically, you can put this on here and I'll spin this around maybe 10 times or so and get this super clean. So I'll prep, so that's nice and clean. I'll prep both sides. I'm gonna flux it and I'll put the joints together. Same thing with all your fittings. This thing again on the this is a 3/4 side. 3/4 inch side. It's got this brush here that you'll take in and clean all this out. So that makes that nice and shiny. That'll accept the solder really well and create a really tight joint, leak-free joint. So we'll end up just another little tip. So I'll do these after I deburr all those. I'll go ahead and clean out all of my fittings first, because these you can set down without getting any dirt in them. But these, as you clean these, I'm going to clean these, solder them up, solder the joint it is, and put that together just so that dirt doesn't start collecting on that, on the flux. So we'll start doing that here in a minute. Alright, let's start assembling. We're going to, again, build this lower section here. So I've already cleaned the inside of all these, the 3 fittings I'm going to use. This T needs to be in this position, this T is clean, needs to be in that position, and then here's, I got one elbow, it's already pre-cleaned. I'm going to need one of my taller pieces. This, I'm going to clean these, I'm going to flux everything, and I'm going to put it all together, but I'll speed that up. Okay, I see one issue I've got that I did not take consideration. That is, this again is shorter than this elbow. So this piece here needs to be shorter. It needs to be one of the shorter pieces. I'll go ahead and use, I've already cut one. It's going to be shorter by that, make that 2 1/4. So let me take this one back out. Let's clean this one up, put it on. Okay, so now all these ended up at the same height. The valves will go on here. I can make sure I can lay this on the table, make sure these are all perpendicular square to each other, and that way they're ready to be soldered. So let's solder all these joints and these 3 joints. Okay, it's time now to solder these together. It's been a while since I've done this, so these are my first ones, maybe a little bit ugly. What I'm going to do is I'm going to do this joint first. I'm going to run some heat on the pipe itself for about 10 seconds or so, just to get some warmth started in there, and then I'm going to move the heat back, and I'm going to concentrate on the back of this pocket, the pocket that the tube is in. They call it the cup. I'm going to move my heat back and forth on this cup and get this super hot, and actually once it gets hot enough where that solder will start melting, you tap it here, it's going to draw it in, it's going to suck it in to that very, very thin gap that's between these 2 pieces of metal, and that's going to then fully encapsulate that. And all I'll do is I'll check the bottom, make sure that the solder went through all the way around. And on 3/4 inch pipe, you want to use about 3/4 inches of solder. So I went ahead and put a little extra bend right there. So I'm going to try and use about that much solder to get this together. So let's give this first one a try. I've got a fire extinguisher here nearby as well, so missing a tip on my thing. I just realized that it may have broke off. Let's see if this will work. If not, I need to buy a new tip for this. Okay, that got that started. Getting close. Alright, then with the damp rag, yeah, it went all the way around. Hang on, I can't see right there. Yep. So let's do the same thing. Rebent my wire. Got that much solder. Let's go with this one. Okay, probably best to do all those when they are kind of do them all together. On that one fitting. Hey, not bad for a rookie. Alright, so I've got this thing in a clamp, in a little vise. I'm going to pull it off and just make sure that next joint over makes a very flat system. I don't make sure these aren't and I'll flip this thing around so we can see that part too. Okay, so everything below these valves is done. This whole section right in here is done. That's below these yellow valves. And then this piece here is this little section, this little dog leg down here. I'm gonna have to add solder another copper connector in there and be able to adapt to this auto drain. Let me show you the auto drain. This is I now can't remember who. Let's see, I got the thing here. Pneumatic Plus. Got it on Pneumatic Plus. Basically, it's gonna provide most of the drainage for about 80 or 90% of the water. Interesting, I didn't realize, but this I believe is a 1/2 inch. I'm going to have to check what type of fitting that is and then adapt. I need to be able to screw into that and solder into this, and that'll be the next little adapter. I've got to go buy that. But that was one of the considerations I had to take. But the key now is, so this bottom section is done, and I need to determine these three pieces here are the same length, and I need to determine what that length is for my space, as well as try and maximize. Ultimately I want this top section here to be about 6 inches below the ceiling, and I want this drain to be about 10 inches off the floor. So first thing I did is I added up the 10 inches plus what I'm pretty sure all this will add up to right here, and it was 32 inches. And I took a 9-foot ceiling minus 6 inches minus the 32 gives me 68 inches. So these three pieces here are going to be 68 inches each. So I went ahead and I've got these now cut, and I'm really ready to assemble. I can assemble another E piece, a T, this 68-foot piece, these elbows, all of this, everything above these valves really now can be assembled. I still haven't determined what this piece is going to be and what this piece is. This right here, where this is located on this leg, it doesn't really matter. You don't want it super, super high, and maybe the lower the better technically, but yet what I want is, because these bowls here, this dryer is going to hook to it, I don't want it too low. I want to be able to see what's going on here because it's got a pressure gauge valve as to what the whole system's pressurized at. So I really want this thing about 4 feet off the ground. So again, if I'm somewhere around a little less than 2 feet to here, and if another 2 feet, that's going to be just less than 48 inches. That's going to be about right. So again, somewhere around 2 feet, if that makes sense. I am going to look at my cutoffs, and I think I'll actually raise it just a little bit. That way I can use some of the cutoffs of these three to make these two pieces, and I'll actually be able to take one of my pieces of copper tubing back to Home Depot and get a credit for that. It was $14 a stick. So I've got these cut. Let me clean up these fittings and mock this all up, and then we'll get that all soldered together. Okay, I just finished dry assembling all the riser components. Up at the top you got the 90-degree elbows coming down there. Right there we got the inlet that'll come out away from the wall and then across with where the filters will be. And the whole time we're maintaining that 4-inch on center dimension. And then down here we have the inlet. The air will be coming in through this this side of this T. And I had to make an adjustment. I completely forgot. But this being an elbow, this center, this not this one's 68 inches. This one's 67.5 inches. I had to shorten it a ½ inch due to the way these fittings, my elbow fittings, are a ½ inch longer. So that middle piece there is a ½ inch shorter. And then this one back here is another 68 inches. And then this one, I actually just left it long. Once I get it all welded up, soldered up, I'll then strike a straight line here and cut that off. And then it's these 3 ends is where those ball valves will go. Okay, those top joints are done. They're all flat. So now we'll work back to the other side and make sure that stuff stayed flat and is the direction we want it all to be on one plane, and then we'll get it soldered up. Okay, those are done. Alright, let's check this for square. And I'm really just going to check just the fitting. And we got that thing all squared up. So let's get that soldered in right there. Okay, well that wraps up the riser section. This is the actual outlet of this radiator. This is where the relatively dry air will come out. It's going to elbow across, and this is where the filters will actually sit across here, and then the flow of the air will go here. And then it's going to go up and immediately connect into that distribution system and get carried out throughout the shop. So according to the diagram, these 3 legs will dump into the top of the valves. That's this yellow piece in the drawing. So all 3 of these should terminate the same length. So now I'm ready to cut this to its final length, and I'll just do a straight edge across here and mark it, and this will tell me where to cut it off. So now all 3 of these will be the same length. The valves will go on here, and then that the very first piece that I built, this lower section, will butt into the bottom of the valves. So at that point, this whole piece is just about done. So what's left will be to finalize the interchange between this copper tubing, which will be below the valve and below this, and this auto drain. I gotta finalize that. I gotta finalize where this comes up and elbows over. This whole section here, how it's going to interface with the air filter. There'll be a quick union right there that'll allow us actually to get it on and off. And then there'll be an elbow here that points up, and that actually connects into this blue MaxLine air distribution system. So we're getting close. Okay, so the valves have come in. These are full port ball valves. The key to the valves is it's a 3/4 inch compression fitting here and a 3/4 compression fitting here. It does have a brass ball in it. It does have a small, I see a looks like a nylon sleeve, but that'll be fine because I'm going to be soldering these, get them hot. The one thing I didn't expect is this handle to be so long, and that may affect a little bit these. I got to make sure it doesn't bind up with these two valves being so close. But I'm going to get the 6 ends all cleaned back up, get these inside sections all wire brush cleaned up, and get this stuff put together and soldered. Be right back. Alright, I got those valves installed, and the next step's going to be installing the connector down here for my auto drain. Here's a Pneumatic Plus auto drain, part number SAD402. It's got a 1/2 inch natural part thread tapered connection here, so I just got to get an adapter that's going to go from 3/4 inch pipe to that 1/2 inch tapered thread, and that's what this little gem's going to do for me. So I'm going to solder this on the end of that. I'm going to clean this up, clean that up, flux it all, and then get that soldered on. So the bottom of this will be done. Okay, got that done. So now the air is going to enter the system via this leg right here. This is going to come from the air compressor. But instead of having my whip cable coming in horizontally, because this whole thing sits up and mounts to a wall, I'm going to put a little dog leg down here. Since I got the extra parts, I'm going to put this 90-degree elbow, a little piece of tube, and then this is a 3/4 inch to 1/2 inch adapter, and then this bushing will get my 1/2 inch down to 3/8, and my whip cable right from my compressor will be able to hook into that. That way that connection will be vertical instead of horizontal, and that'll just make it last a little bit better. So anyway, I'm going to add this now to my inlet side. Okay, so now I'm ready to put together the post filter system. And just to remind you, the air is going to come in from my compressor into this inlet. For the most part, the flow of the air is going to go up over this hoop, down here, up over this hoop and come down. It's going to exit this radiator right here. And then it's going to cut across this diagram and in this assembly right here. And this is basically after it's been dried through the radiator and cooled, then it's going to go through this final dryer and oil separator. And so I went ahead and drew this out and actually kind of blew it up so I could figure out exactly what the pieces I need, because I went and had to buy a bunch of adapters, and I wanted to know exactly what I needed to buy. So I've bought all this stuff, and basically it's coming out of the radiator, I'll have a 90-degree elbow, and then a small piece of 3/4 inch pipe, and then this junction. I'll need this junction in order to because it's got these bends in it, and it's the only way to be able to hook it together. So I'll have what they call a union, 3/4 inch to 3/4 inch compression fit, another 3/4 inch piece of pipe, and then I'm going to go 3/4 inch to 1/2 inch. That's this piece. Interestingly, on this, when I bought this, I didn't realize it, but I bought 3/8 inch tapered thread on either end. So I got to neck this down to 3/8. So I'll go it'll go 3/4 inch to 1/2 inch. Then this is a bushing 1/2 inch to 3/4 inch, and then this is just a male to male, because that'll plug right into there. So that's this side. That gets me to here. Then I've got the filter itself, and then I just do the reverse of that with this guy, 3/8 to 1/2 inch to 3/4 inch. To a pipe, to an elbow, then I'm going to have it go up. It's going to go up, and then this is where it'll exit and go into my distribution system. It'll just distribute throughout the whole shop, as well as right here locally I want to create a drop as well. So I'm going to come off with a T and an elbow and come down, and this will be right here I've got 3/8 inch quick connect that I'll put at the end of this drop right here. So I'm going to get that all assembled. Each of these I'll use some pipe thread tape to secure this, but I'm going to get anything I need to get soldered. I'm going to get those pieces soldered up first, and then we'll start taping this stuff together. Alright, and then one other thing I want to show you is I went ahead and detailed, over here, I detailed all the pieces that I'm using, the quantities, and I use this to go shopping. I'm going to put these 3 sheets of paper together in a PDF file and allow you to download these in case you want to use it as a reference. So down in the comment of this video there'll be a link to a 3-page PDF document that you can download, print out yourself, and it'll be coming off my my Google Drive. So let me start getting this stuff assembled.
put any kind of glue in between the fittings?
No, but the flux.
Oh yeah. Because I can see it bubbling.
Okay, so I've got the filter inlet section mocked up, and actually it's all soldered up and ready to go, and I got the filter exit system all mocked up. I wanted to dry fit this just to see how wide this was, because I do have a small wall I want to put this on, and I'm really trying to create something that's kind of compact. That's why the air flows through here then doubles back. It's just a compact system. And what I realized is this is a lot wider than I expected. I didn't anticipate this to be this wide, and so I'm going to make some changes to my design. And that's kind of the neat thing about having your own design, or at least understanding how it works, is you can make modifications. I wouldn't want to build this and just live with it because this is the way it was designed. So I'm going to change my design. First thing I'm going to do is I'm going to take apart this solder joint here. I'm going to clean up this completely, and I'm going to rotate this 90 degrees. So this spigot here, this is an outlet where I can connect to an air source. This T will come out away from the wall. It'll come out here and then put down here. That'll save me that 4 inches. And then also for this section, I tried to critique this. What can I do differently in here to make this shorter? And the key is this thing doesn't have to be part of the horizontal distance. So what I'm going to do is I'm actually going to take this piece and rotate it up, and I'm going to take this solder joint apart. I'm going to put an elbow here and have just the elbow, a small piece of pipe, and this fitting come out. That's going to save me 3.5 inches. This thing will then mount up here about like this, and that's more what I was looking for. Actually, it'll end up about right in here. So I'm going to modify this, and I'm going to modify this. And once I get that done, then we'll talk about kind of some of this threading stuff and get all this put together. So let me work on that. Okay, so here's another dry fit. I was able to take this union, instead of it being part of the horizontal component, it's now part of the vertical, and what that did is allowed me to take that junction piece right there, and it's moved now that way 3.5 inches. That took this whole thing and shifted it over more in front of my radiator. And as well as I took this leg, it used to hang out here and go down. Just by soldering this, unsoldering this joint and rotating this 90 degrees, I was able to pull this, and that way it's off the wall. I kind of actually like this a lot better. So now I've got 4 inches, 4 inches, 4 inches, and I'm not sure what this is, something about 4 inches. So it's basically about 16 inches wide. The wall that's going to go on is a concrete wall, and it's 20 inches wide. So there's going to be a little space on that side, and about 2 inches there and 2 inches here. This is going to be perfect for the space that I'm needing. So now this is all dry fit. I'm going to take this apart, and we're going to basically put some thread tape and get all this more permanently mounted. Let's work on that. Okay, now we're ready to thread tape our joints. This piece kind of goes together. There's two things I'm going to mention, very logical about thread tape. First of all is you need to wrap it in the right direction. Imagine that the fitting that's going to go on this joint is going to go this direction to tighten. That's the direction you want to wrap your pipe tape so that it overlaps this way. As you're putting that fitting on, it's actually tightening the tape. If you were to put it the other direction, it would, or imagine the nut tightening this direction, it would be actually trying to unravel it. It'll bunge it up. The second thing is you want to make sure once you get finished applying the tape, you want to make sure you clean off anything in the end. You don't want anything toward the inside. So we'll do both of those things real quick. I'm going to pull off about 1.5 inches of tape. Cut it. Apply it. Rotating it in the right direction. Okay, so again, as the ends come in this direction, as I tighten that thing on there, it's just going to continue to tighten that tape, and that'll make that work. The next thing we'll do is we want to chop off this excess stuff here. So I'm going to grab it right here and pull. It actually tears this direction very easily. There we go. Okay, so we got nothing on the inside. All the tape's on here. It's on the right direction. We'll put this on here. Then I'll use some crescent wrenches to tighten that down. I'll do this all off camera because this stuff I'm going to be wiggling all over. And then we'll get that nice and snug. And we'll continue that process for all the rest of these joints and bring you back when I get it done. Okay, so the filter assembly is all complete. That's all finished fitted, and I've got it mounted to a board, so it's spaced off the radiator just right and all secured. As well as I went ahead and put a cleat up at the top, mounted it with some brackets, and I'll put some holes in that, and then as I transfer this thing over to the wall I'll mount it on, then I'll transfer those hole spots and put some concrete anchors in. It'll be anchored at the top and as well down here at the bottom. But I'll tell you what, I've critiqued my design, and I've got another change I'm going to make. Okay, so my air's coming in through this whip line and coming into the system here, going through the radiator and exiting it through the filter. I did this with a lot of thought. I said, you know, I'm going to put this down so this hangs naturally, so this won't have a weird bend in it and that type of stuff. This was on purpose. But now that I think about it, what's going to happen, again, this thing's hanging on a wall, right? This is the bottom end, and the top end's up there. What I don't want is my air compressor exit to be here, come down, and have this tube dip down below all my drainage points. Otherwise, what's going to happen is this thing's going to fill with water, and it'll never get drained. In fact, this is the first part that hits it. So, and I see that on, I made note of that when I looked at a lot of other people's videos. There's a lot of hoses that are below all your drainage spots, and that's just not right. So I'm going to change my design. I'm going to flip this thing 180 degrees. And even though it won't be support, I won't have that support, I'll have a way to hook it onto the something just so it'll come down from here, so that the tank will have a low spot, but it's got a drainage. Once it comes out of the tank through the whip cable and comes into here, it'll have a drainage. So there won't be any place that there's a low-lying spot that water can sit. So I'm going to get this, I'll undersolder this here, get it all cleaned up, reverse this to the top, and resolder it, and then I'll be done, and then I'll be hanging this thing. Okay, so I got the inlet now reversed. It's now going to feed from the top. That's going to help keep any water out of that whip cable. And I've also mounted this thing on the wall, so it's now mounted. This is kind of the lower section down where the manifold is. And then it goes, this is about eye height. This is going to be where the filter, and it's got the pressure gauge, as well as an exit point for just a local air supply. And then on the far right is where it'll hook into my distribution line. And then it also goes all the way up there. This is mounted against a concrete wall, which stays relatively cool. So that's going to actually help that copper stay cool and do its job and take moisture out of the air. And what I want to do is I want to spend a minute about something I kind of came up with. It's just a little bit different down in this bottom section. I'm going to explain how this works and why this thing is going to be semi-auto siphoning. It's kind of a neat little concept I came up with. Let me go over that with you. Okay, so in this system, again, the air is going to enter the system in from the air compressor from this side. It's going to go up to the top over the hoop and back down. It's going to go up over the hoop and back down. Imagine these valves being closed. This is a closed system. Water will condense and drop down into this section. It'll condense from either one of these two pipes and drop down to this section. And then the same thing, any water that's in this pipe will drop down to this section. With these valves all closed, this is kind of a typical what you see people building these days. And that's the water will sit here until basically you decide to go bleed some of that water off. And you'll open the valve and it'll bleed it off. My thinking is, as I wanted not only just that then to fall onto the ground 3 different spots, I wanted to create this discharge manifold at the bottom so that it would all discharge into one spot and I could put a bucket under this. Well, then I continued to think about it. I said, well, what if I put an auto drain on here? And then what I'm going to do is, I'm in my normally operating position, I'm actually going to leave this valve open. Now what's going to happen is, let's say we run 120 psi in the system. There'll be 120 psi in the upper radiator as well, as because this valve's open, this will be 120 psi as well. The whole system will be 120 psi. But any water that comes through this first stage, and this is where I believe most of my water is going to be collected, it'll drop down, and instead of just sitting on top of this valve waiting for me to open, it'll drop all the way down here and sit. When this thing fills up, it'll auto discharge that water. Now, I've got to keep these valves closed, because if these were both open the whole time, then air would simply come through and come this easiest path and get out and never potentially move through these systems. So I'm going to keep these normally closed, this one normally open. Any moisture that's dropped out of the air in this first section of this radiator, it'll actually auto siphon. It'll blow out to the bottom, and I'll put a catch pan down there. And then just occasionally I'll come through and I'll bleed off these 2 sections by opening these valves. Now, if I can determine that there's actually, because this trough actually has 2 pipes that it's servicing, if I determine that this section of this machine is actually pulling more water out than this first section, then I'll run this with this normally closed and this normally open and run it like this. Therefore, water will trap and get stuck here, and it will only open up until release until when I open the valve. But any water in this larger section that goes will automatically drain out of the system. And I'll have to keep this closed again to keep the shortest path from happening. With this scenario, the air is gonna flow through my radiator like it's supposed to, and pull out all the moisture that it can. So at first I'm gonna operate this like this and see how that works, and just maintain it that way. So I thought that was a pretty good way of doing it. That way I can get, I'll just have to bleed off these couple valves occasionally. So next I'll have to work on the max line distribution system and get it distributed throughout my shop.